Good morning. Today we want to see about the fixed voltage regulator. So we will wait for other students for 1 minute. Until that, we will revise our previous session. So in previous session, we have studied about the voltage regulator. We are using voltage regulator to maintain constant DC voltage at the output irrespective of the voltage fluctuations at the input. It means what? If there will be the change in input voltage, or there will be the change in temperature, or if there is a change in load, at that time also we are preventing that fluctuations and we will get the constant DC voltage at the output. That time we are calling that device as a voltage regulator. So we can say we are using voltage regulator to maintain constant DC output voltage. So here you can see there are the different types of voltage regulator. Is there any issue? Okay. Kamla, my screen is visible. Voice आ रहा है अच्छी से?
Yes, ma'am.
Okay. So you guys can mute yourself and focus on the class. So what we are doing here, we are using voltage regulator to maintain the constant DC voltage irrespective of the voltage fluctuations at the input, or there are some variations in the load current, because we have seen about the three types of regulations which we are doing in the voltage regulator. We can see here, these are the performance of the voltage regulator. We can maintain line regulation, load regulations, or temperature stability. It means what? If the load current is changed, the load resistance value is changed, if the input voltage change, or there is some differences in the temperature, at that time also we are maintaining constant output voltage. That means what? We are irrespective of the changes at the input, and we are putting output voltage constant. So we can see here, if we want to measure the line regulation, we can measure it is the ratio of change in output voltage with respect to change in input voltage. And we know what we are doing by using the voltage regulator. We are maintaining the constant DC voltage irrespective of the change in input voltage. So delta is nothing but change in, and we know there will be no change in output will remain constant. It is nearly about the constant. It means what? It will have approximate constant value. So we can calculate line regulation as delta V out upon delta V in into V out into 100. टोटल जो है उसको 100 से मल्टीप्लाई करेंगे. If we want to calculate load regulations, it is related with the load. It means what? If there is a change in load value, at that time also we are maintaining constant DC voltage. It means what? Constant output DC voltage will not depend on the value of load. If there is no load, or if there is a full load, it will not depend. So we can calculate load regulations as the ratio of, it is the ratio of change in the load value with respect to the full load. Just wait for me. ऑडियो ओपन नहीं हो रहा है. ओके, जस्ट वेट. Okay, so here we see about the load regulation. If there is a change in the value of load, at that time also we will get the constant value of the DC voltage. Then we have seen about the temperature stability, and what we are saying, if the value of temperature will change, at that time also we will get constant DC voltage, and we are calling that as a temperature stability parameter of the voltage regulator. टुडे इज इशू इन इलेक्ट्रिसिटी. तो लैपटॉप में चार्जिंग है, बट फिर भी मतलब यदि यहाँ पे लाइट नहीं है तो मतलब लैपटॉप डिस्चार्ज हो सकता है. तो कॉल यदि डिस्कनेक्ट हो गया तो आई विल शेयर माय रिकॉर्डेड वीडियो विथ यू. ओके, हाँ. And today there is a test for the electronic circuit. I will share you the link. You guys are supposed to give the test till today evening or till today night. Okay, link will be valid till 10 p.m. So here now you can see I'm just putting your attendance. Okay. So you can see here. Now we have to see the difference. There are the different types of the voltage regulator. What we are saying, we can maintain the constant output DC voltage irrespective of fluctuations of the input voltage, of the load resistance, and of the temperature. So there are different types of the voltage regulator like series and shunt regulator. So Zener regulator and transistorized emitter follower regulator, these are the types for the series voltage regulator. And shunt voltage regulator is nothing but error amplifier voltage regulator. Then there are different types of the voltage regulator which are related with IC. We are having the IC which will give fixed voltage or which will give variable IC voltage. That means what? Here if you see the series of IC 780XX. XX is means these are the don't care. So you can put here any number like 7802, 7805, 7809, 7812. That means what? They are giving that much voltage and that voltage will be fixed. So this type is called the IC78XX series is called as the fixed IC voltage regulator. And variable means we are having in our syllabus IC 317 and IC 337. These two types of IC will give variable voltage. So we can call that IC as the IC which will give variable IC voltage. So we can call this IC as a variable IC voltage regulator. Again, there is a switching regulator. It means what? If we are boosting or we are bucking or if we are buck boost, it means what? We are inverting the input voltage. That time we can call that voltage regulator as a switch regulator or we can call that regulator as a flyback. Here we have to see one by one. So here in our syllabus we have to see fixed IC regulator. So firstly we will see about the fixed IC regulator. We have seen 78XX series. We are calling it as a fixed voltage regulator. Why? Because these IC will have unregulated input voltage. But what will it do? It will convert that unregulated DC input voltage into the regulated output DC. मतलब क्या? हम यहाँ पे जो input दे रहे हैं, it is also a DC voltage, but it is not a regulated. It is not a constant value. So here by using the 78XX series, we can convert that unregulated DC voltage into the constant DC voltage, or we can say that will be a regulated output DC voltage. So here if you see the structure for the 78XX regulator, it will have three terminals. Three terminals. One terminal we will give here input DC voltage, but that will be unregulated. You can see here this is the circuit diagram and how it will look like practically. So it will look like IC because we are calling it is a 7xx IC series. तो ये क्या है? ये ऐसे practically if you see the practically it will look like this and it is having three terminals. So here we will give input voltage that will be unregulated. ये जो वन नंबर है and second terminal we are connecting it to the ground because whenever we are measuring input voltage, whenever we are giving the input or we are measuring the output voltage at the output terminal, at that time what we can do, we can put here voltmeter. प्रैक्टिकली तुम क्या कर सकते हो? वोल्ट मीटर रख के वहां का वोल्टेज मेजर कर सकते हो. तो तुम क्या करोगे यहाँ पे? यू विल पुट पॉजिटिव टर्मिनल टू दिस टर्मिनल, पॉजिटिव, ये जो थर्ड पिन है, and you will put the negative terminal of voltmeter to the ground. So here if you see the circuit diagram for 7xx, second terminal is reserved for the ground and third terminal it will be acting as a output. So you can see this is the pin diagram for the 7xx. It will look like this. It will have three terminals. So we can see 7xx series is a three terminal device and it will convert unregulated DC voltage into the constant DC voltage. So here it will require three terminal, one terminal. At one terminal we will give input. At second terminal we will connect it to the ground, and third terminal will be reserved for the output. So 7 at XX voltage regulator will produce positive DC voltage irrespective of fluctuations at the input DC voltage, and 79XX voltage regulator will produce DC voltage, but that will be negative. So here we can say 7 at XX series will give positive DC voltage that will be fixed, and 79XX will also give DC voltage that will be constant, but it will give negative. These are the differences between 7 at XX fixed voltage regulator and 79XX voltage regulator. So here if you see, we are having the different type of positive voltage regulator in 7 at X series. If we are having IC that is called as 7805, so we can take output voltage as a 5 volt. That will be constant. That's why IC को ही नाम दिया है directly 78 or don't care की जगह we are taking here 05. So it will give us constant fixed output DC voltage that will be the positive, and it will give 5 volt. If there is 7905, that time it will also give a constant output voltage, but that will be negative. So here we can say if there is a 7905, it will give negative voltage, and that will be a fixed voltage, but it will have minus 5 volt voltage. If we are using 7806, it will give constant DC voltage as a 6 volt. Like this, we are having different number of IC available in a market. If there is IC, it is called as 7824. It will give constant DC voltage that will be 24 volt. And here, what we are saying, it will convert DC voltage into the constant DC. So input voltage for the 7805 minimum value will be plus 7.3, and maximum you can take any value up to 35 volt. So here we can say if we are having the IC 7805, that is a fixed voltage regulator, so it can convert unregulated DC voltage 7.3 into a constant DC voltage of a positive 5 volt. So these are the minimum voltage here they have given. And what is happen? It can convert that unregulated voltage into a constant. You can see here it will be 27.1, or it can be a 27.9, or it can be a 26.5. It will approximate value. But whenever it will converted to the constant DC voltage, that will have fixed 24 volt. So we can say fixed voltage regulator will convert unregulated DC voltage into a constant DC voltage. So here we can say this double X, 7 double X, we are using that series. So double X series will respond to 2-digit number that represent the amount of voltage we will get at the output of fixed voltage regulator. So here 05, it means what? It will assign value which will get at the output, and that will be 05. It is nothing but positive 5 volt. So here both 78XX, 79XX will have 3 pins, and 3 pin means what? We are saying one number pin is used for input, 2 number pin will be reserved for ground, and 3 number pin will be used to collect the output from that voltage regulator. If there is 78XX series, it will give positive voltage, and if there is 79XX series, it will give negative voltage. Okay. So you can see here. So the series 79XX regulator, what we are calling, it is also a fixed voltage regulator, but it will give fixed negative voltage regulator.
गोळ्या करायला नव्हतीस ना तेव्हा.
Pradnya, please mute yourself. Already here is the issue of electricity, so just see here, we are not having that much time. So here we have to see about the 79xx voltage regulator, and what we are saying, 79xx is also a fixed voltage regulator, but it will provide us negative output voltage irrespective of fluctuations at the input AC voltage. Its constructions will be exactly similar with the 7 at XX. Here, first terminal will be reserved for input. Third terminal, here we can collect our output which we will get from that IC. And second terminal, we are supposed to connect that terminal with the ground terminal of the voltage supply. So here we can say this series of 79xx voltage regulator has the same feature and the characteristics as of the 78xx fixed voltage regulator, except the pin numbers are different. Why? Because here we are taking the negative input, and in 7xx we are taking their, you can see here, we are taking their positive input, we are measuring output as a positive, but here in 79xx here is the negative output and the negative input. Remaining construction and features characteristics are same. Again, if you see the structure, if you see the different number of IC for the negative voltage regulator, in 79xx series we are having number of IC available in the market, which will convert unregulated DC voltage into the regulated DC voltage, but that voltage will be a negative. So here if we are having the IC 7909, so here negative input voltage minimum value will be minus 11.5. It is approximate value, and we can convert that unregulated value into a constant minus 9 volt, because this xx of 79, what they are defining, they are defining the value of output DC voltage which it will give. So it will give 7909, it will give 09, but we are saying 79 double x is a negative voltage regulator, so it will give minus 9 volt voltage at the output. So what we are saying, we are having different types of the voltage regulator, that are fixed voltage regulator and the variable. So in our syllabus, in fixed voltage regulator, we have to see 78xx and 79xx. So we have studied all this. Another type of voltage regulator, we are saying it is a variable. So we can say it is as a adjustable voltage regulator. If you see the circuit diagram, block diagram for the LM317, it will look like this. And what we are saying, by using the 317 or 337, what we can do, we can convert voltage to the variable voltage. You can see here, input voltage is from 3 to 40 volt, and we can convert that voltage into a variable value, and we will get at the output 1.2 to the 3.7 volt voltage. So what we can say, by using the LM37 voltage regulator, we can produce desired positive voltage that will have variable range. That will have variable range from 1.2 volt to 37 volt. So here we can use LM317 pin. It will also as a IC, and it is also having a 3 pin. You can see here the circuit diagram for the LM317. 78xx, 79xx, they are also having the 3 pin. So what we are saying, LM317, it is a variable or adjustable voltage regulator. Its typical connection diagram will be look like this, and it is also a 3-terminal device. It is also having a 3-terminal. The first pin is used for, here you can see what I have written here, adjust. It means what? This pin is used for adjusting the output voltage. First number pin is used for the adjusting. Then what we are saying, second number pin. Second pin we are used for collecting the output. और 78xx 79xx में हम क्या करते थे, फर्स्ट नंबर को हम इनपुट देते थे, थर्ड नंबर को हम आउटपुट देखते थे, and to the second pin we are connecting to the ground. But here what we are doing, here we are using first pin for adjusting the output voltage, and second pin we are used to collect the output DC voltage that will be variable. Again, third pin we can use to give the input voltage. So here if you see, here we are giving the input, so that will be the third pin. Here we are adjusting, that will be the first pin. And here we are measuring the output, that will be the second number pin. And if you see at the output, what we are using here voltage divider. You can see we are dividing that voltage. Why? Because here if you see, we are dividing the voltage because here at the output of LM317 variable voltage regulator, we will require voltage that will be variable. So we can adjust the value of voltage. Here we are using rheostat. If you see the diagram, here we are using, these are nothing but the rheostat. So what we can say, by using the LM37 voltage regulator, we can produce output DC voltage of available voltage range. Here we are giving input voltage that will be from 3 volt to 40 volt, and we can get output voltage, we can collect output voltage from 1.2 up to 37 volt. That will be variable, it is having the variable range. So this is the LM317 IC, and if you see the output voltage value, that will be 1.25 into 1 upon R2 plus R1 plus the value of R2, because we are taking that resistance as a rheostat. So here we are using variable resistance. So this is the circuit diagram for unregulated power supply by using the LM317, because here we are regulating, but that at the output we are getting the output that will also a variable range. And here we are using at the output voltage divider, and that value of resistance R2 is variable, we can change that value. If you see the 337, you can see here the LM337 is also a variable or a adjustable voltage regulator. Here it will exactly similar with 317, but only difference will be, it will take input voltage that will be a negative. Range is also same 3 to 40, but here it will take minus 3 to minus 40 volt, and at the output it will give the fixed voltage, but it will have variable range. So you can say we can adjust the value of output voltage that will be negative from minus 1.25 to minus 37 volt, and it will happen at the my it will happen at the 1.5 ampere. So what we can say, by using LM317 and LM337, we can convert input voltage into the variable or adjustable DC voltage at the output over the load current of 1.5 ampere. And here we will get the output range that will be adjustive from minus 1.25 to 37 volt. If you see the pin diagram, you can see here. If you see the circuit diagram is also same. It will also same, but what is the difference? One pin number will be adjustive the same to adjust the output value. At the pin number 2, we are giving here input, and at the pin number, wait, at the pin number 2, we are measuring the output, and at the pin number 3, what we are doing, we are giving the input. But what is the difference here? In LM317 we are giving positive input, and we are measuring at the output positive voltage. But in LM337, input also a negative, and at the output we will get the negative output voltage that will have the variable range. So this is the circuit diagram, pin diagram, and How it will look like? Practically, it will look like IC, which will have three terminals. One terminal for adjusting the output voltage, two terminal, and these two terminals remaining for taking the input and giving the output. If you see the features, you can see here. The output current will be in the excess of 1.5 ampere. Here we can adjust the output by using the LM37317. You will get 1.2 volt to 37, and by using the 337 you will get output voltage that will be variable or adjustable in between minus 1.2 to minus 337 volt. Then internal thermal overload protection, because here we are using the rheostat, so we can adjust the value of the resistance. Internal short circuit limiting constant with temperature. These are some of the features of the LM317 and the LM337 voltage regulator. Current boosting we will see in next class. Okay. So if anyone is facing any issue, you can ask me. So in today's session, we have seen about voltage regulator. There are different types of the voltage regulators, fixed and the adjustable voltage regulator. If you see the fixed voltage regulator, in our syllabus, we have to study IC78XX and IC79XX voltage regulator that will give fixed output voltage, and variable voltage regulator we have to see 317 and 337. So 78XX will give the value as output will be a positive. It will give fixed output voltage that will be a positive. And 79XX will give the output DC voltage that will have the fixed value, but it will be a negative. And IC317, if we are giving the voltage from 3 volt to 40 volt, it will give output voltage that will have variable range, but it will be positive. And if you use 337, it will take input voltage and it will convert that input voltage unregulated, it will convert it into the regulated, but it will have the variable range, but that will be a negative. So here you can see, if you see the 78XX will look like this. It will be a three terminal device. First terminal will be reserved for input, third terminal will be reserved for collecting the output, and second terminal we will connect to the ground. If it is a 78XX, we will give here positive input, and at the output we will get positive output. If it is 79XX, then at the input there will be a negative input voltage, and at the output also we will get fixed output voltage, but that will have the negative value. And if you see the structure, features, characteristics of 78XX and 79XX, all are same, remaining the pin numbers, because here in 78XX we are giving the positive input and we are taking the positive output, but in 79XX we are giving negative input, and at the output we will get negative output voltage. If you see, these are some 7905 up to 7924 number of different IC available in the market, which will give negative input voltage from minus 5 to minus 24. If you are using 7918, that time it will only give minus 18 volt at the output, that will be fixed. In now we want to see variable voltage regulator. In our syllabus we have to study LM317 and LM337. If you see, this is the block diagram for the LM317 by using the transistor. It is a amplifier and it is the transistor. What we are doing here, by using the LM317 power supply, we can regulate input voltage which is having range 3 to 40 volt. We can convert into a positive 1.2 volt to positive 37 volt. It will be appeared at 1.5 ampere. If you see the pin diagram, it will also a 3 pin IC. Here we are using first pin terminal, first pin of the LM37, which will be used for adjusting the output voltage, At the second terminal, we are measuring output voltage, and at the third terminal, we are giving input voltage. LM317 will give the output voltage that will be variable and it will be a positive. If you see the LM317, you can see here 337. This is the typical connection diagram for the LM337. It will exactly similar with the adjustable voltage regulator LM317 except the pin numbers, because here we are giving the negative input and at the output also we will get the negative output. So here pin number 1 will be used for adjusting the output. Pin number 2 we will take here the output voltage, and at the pin number 3 we will give input voltage. If you see the block diagram, it will be look like this. And if you see, there are some features of the LM317 and LM337. Okay. Sneha, is there any issue? Okay. Here we have finished our fixed and variable voltage regulator. So our next topic is nothing but current boosting. We will see in next session. Now I am taking your attendance. Okay. If anyone is facing any issue, you can ask me. I will share the link for test right now. You guys are supposed to give the test till today night. Test will be valid till 10 p.m. Okay. Thank you.